Linear applications of op-amp inverting amplifier. Input is applied to the inverting terminal of op-amp and the non-inverting terminal is grounded. Here input resistance R1, feedback resistance RF. Non-inverting terminal is at the ground potential. It is VB is equal to 0. And, due to virtual ground, VA is equal to VB is equal to 0. The input voltage is applied to the inverting terminal through resistance R1. The current flowing through the resistance R1 is I is equal to Vn minus Va upon R1. The current flowing through resistance RF is Va minus Vo upon RF. Since the Va is equal to 0, same current flows through the resistance R1 and RF, so that due to infinite input impedance, the input current of op-amp is 0, so that I is equal to Vn upon R1, I is equal to minus Vo upon RF. And so that equating the equations for the currents, Vn upon R1 is equal to minus Vo upon RF. The gain of the amplifier is minus RF upon R1. The negative sign indicates the 180 degree phase shift between the input and output. Gain of the amplifier is less than greater than or equal to unity depending upon the value of RF and R1. The non-inverting amplifiers and RF. The input voltage is applied to the non-inverting terminal of the op-amp. VB is equal to input voltage due to virtual ground. VA is equal to VB is equal to input voltage. The current through feedback resistance RF is Vo minus Va upon RF. Similarly, current through the input resistance R1 is I is equal to Va minus 0 upon R1. Due to infinite input impedance, the input current of op-amp is 0. Same current flows through R1 and RF. Equating the equations for the currents, Vo minus V input upon RF is equal to V input upon R1. RF is equal to V input into bracket of 1 by RF plus 1 by R1. What is equal to V input R1 plus RF upon RF R1 and RF. Therefore, output voltage is equal to input 1 plus RF upon R1. Gain is equal to output voltage upon input voltage is equal to 1 plus RF upon R1. The output voltage is always more than the input voltage. The no phase shift between the input and the output voltage. By controlling RF and R1, here the waveforms for the inverting and here the input voltage, and here it is the inverting input voltage, and for the non-inverting amplifiers, here it is the input voltage and here it is the greater than the input voltage, 2 times the input voltage. So that here the output voltage is always more than the input voltage. No phase shift between the input and the output voltage. By controlling RF and R1, the output voltage can be controlled. The gain of the amplifier is always more than the unity. Now, determine the voltage gain of the op-amp circuit as shown in the figure. The gain is A is equal to output upon input minus RF upon is equal to minus 4.7. The voltage is 4.7. The negative sign indicates 180 degree phase shift. A sine wave of 0.5 peak voltage is applied to the inverting amplifier using R1 is equal to 10 kilo ohms and RF is equal to 50 kilo ohms. It uses the supply voltage of plus or minus 12 volt to determine the output. And sketch the waveforms. If the amplitude of the input sine wave is increased to 5 volt, what will be the output? Is it practically possible? Sketch the output. Gain is equal to A is equal to output upon input is equal to minus RF upon R1. 50 upon 10 into 10 to 3 is minus 5. Output voltage minus 5 into input voltage is equal to output is equal to minus 2.5 volts. The amplitude of sine wave is increased to 5 volts, that is output voltage minus 5 into 5 is equal to minus 25 volts, so that the saturation voltages of op-amp are plus or minus 12 volts. The output is limited between plus or minus 12 volts. The portions of the input voltage above plus or minus 12 volt is clipped off at the outputs, so that here if the input is increased to 5 volts, that is the 5 into 5, it is the volts, and here 25 volts, but here plus 12 volts, and here it is minus 12 volts, so that the plus 25 and plus 20 plus 25, but here it is minus 25, but here it is plus 12 volts minus 12 volts. For the op-amp configuration as shown in the figure, gain required is 61. Determine the appropriate value of the feedback resistance. The solution is that A is equal to output upon input voltage plus RF upon R1. Configuration is non-inverting amplifiers, so that 61 is equal to 1 plus RF upon R1. Around 61 minus 1 is 60. RF is equal to 60 kilo ohms. So find out the output for the circuit shown in the figures. Here the